I think it's time to get some advice from the real pros here. And to call on folks, we are going to ask you, and I hope you'll, out of respect for your colleagues, hold your comments. We said 2 minutes. We'll allow 50% overrun, 3 minutes. But we really would like to cut it off because we want to hear as many people as we can. And I can't see anybody out there, so you'll have to sort of control your own, maybe line up or whatever you want to do. Is there one microphone or two? Or
just got two.
It's a big black room from up here.
Yeah, we're kind of like we're sitting in a furnace and looking into the darkness up here. And so why don't we start out? We'll go back and forth, mic to mic. I think we have two microphones. And please do stick to 2 or 3 minutes. I'll try to remind you, but I'd like not to have to.
All right. My name is Christopher Carson. I'm a resident of Fort Worth, Texas. Chairman Augustine, honorable members of the committee, there's something I want to bring to your attention. There's been very little discussion of the fundamental basis of manned spaceflight operations, which breaks down really into two halves. There's exploration and applications. Now, Apollo was purely an exploration program as far as it went. There was an applications component, and that got the axe, except for Skylab, which we did very little with. And Shuttle was purely an applications program. The idea was we would fly the space transportation system, we would integrate not only Shuttle but also Station and the orbital transfer vehicle, and we would be able to do a lot of unique things. We would fly 50 missions a year. We would take, you've got human-tended experiments, you've got down cargo, you've got the possibility for human-tended orbital platforms. And all those things were in the sort of developmental stage when Challenger was destroyed, and there was this great cutback. And a lot of those things were just eliminated until we got towards the ISS era. And then, of course, we had Columbia, and again things were cut back and back and back. And for the past few years, we've been doing 2 or 3 manned space missions a year, which is not anything like the number necessary to realize the applications potential. Now, the great weakness of the Constellation program is it takes that absolute minimum level of manned space activity as a maximum, as a baseline. Constellation Ares Orion is designed around 2 missions per year. Ladies and gentlemen of the Commission, if you believe that that is acceptable, you have betrayed the dream and you are unfit to sit in this committee. Now, that said, I am going to give you a suggestion. I suggest that manned space program activities immediately be realigned to an applications section and an exploration section. The applications section will focus on things that aren't really NASA's job, but that NASA gets involved in anyway because NASA is the only people doing these things. And that is things like manned on-orbital experiments, that type of thing. And you need to immediately partner with anybody who's interested. I'm not just talking Lockheed and Boeing. I'm talking any possible commercial partners, because that way you can bring in their money. Now, as we saw in the early shuttle era, NASA was only able to do this by offering very large discounts, very large subsidies. But if you actually get some level of involvement, and particularly once you get in COTS and specifically COTS D, the manned orbital transportation, the quantity of subsidy necessary declines substantially. Then the exploration segment focuses on the things that NASA does, core NASA competencies, which require, as much of NASA's current activity does not require, things which actually require NASA-owned and NASA-operated assets.
All right, can you wrap it up? We're over our 2
Well, what
minutes
I'm going to
already.
suggest is simply that those jobs you're worried about losing can be found much more profitably working with industry to do something useful rather than just to preserve themselves. Anyway, I thank you, gentlemen.
thank you for your comments. Yeah, you time them and interrupt.
Okay.
See, there's a
I've got the
microphone over
gavel
here.
now. Look out.
First of all, thank you very much for the opportunity to comment. I'm Dave Hook. I'm the president of Plain Hook Aviation Services. I'm also the producer and the host for a show called Space and Security News for Space Entrepreneurs. And based upon the collective wisdom gained from the many guests to my show, I find 2 major topics which are relevant to the committee's charter. First, I wish to state that safety is a misnomer when it comes to practical considerations of manned operations in space. Space as an environment is not safe. We make use of risk mitigation measures to lower the mission risk to an acceptable level, but in the pursuit of providing a public image of relative safety, I think we've pushed the risk acceptance levels too low. Now, I have no desire for our astronaut corps to suffer the loss of life while conducting space operations, but I do think that the institutional thinking that comes from a risk-averse culture seeps its way into other governmental bodies, and these bodies have the ability to regulate commercial spaceflight operations, manned and unmanned. Therefore, I request you consider a recommendation that NASA examine its current risk calculus for processes and measures which are outmoded and no longer relevant, and either update or dispose of them. Second, I find one particular program that is at odds with the Charter to seek innovation, affordability, and sustainability, and that program is ITAR. The International Traffic in Arms Regulation, as it's currently written and applied, is a self-imposed trade barrier against the citizens and commercial entities of the United States. ITAR keeps U.S. companies from competing fairly in international markets, and it hinders them from establishing sustainable research, development, acquisition, and procurement life cycles. It is this international market which allows other industries to weather poor economic environments within their own homelands and sustain themselves with the positive economies abroad. As it's currently standing, ITAR is an interagency quagmire. In short, you cannot truly have an innovative, affordable, and sustainable commercial space industry while clinging on to an outmoded program like ITAR. I would ask that the committee challenge the regulatory assumptions put before it to see if they truly remain relevant to the 21st century. Thank you very much.
Thank you.
Yes.
I'm Jon Struggle from Austin, Texas. I'm just going to go down sort of a list of major points. First of all, it's much more important to design to reduce operational costs than it is to merely reduce the development costs, because the shuttle, they made have saved $10 billion in their development costs to go to the shuttle we have today, but they've used up an additional $100 billion in operational costs. So this is clearly something in terms of like reusable versus expendable vehicles is very high on the priority list to think about. Okay, then also we should give full support to COTS D funding for other companies to be able to launch people for NASA. And I would think we should also try to retire the shuttle by 2011 to reduce cost of losing the entire program due to another catastrophe and the political reaction to it, which is another cost that should be added to the list. We should guarantee that NASA's future research for the future funding of about 5% of the annual budget for things that have been just chopped off for the last several years. They should be reestablished. We should shift surface-to-Earth launch operations from NASA to private companies and let NASA focus on those things that it's good at, such as designing and building a set of fully reusable in-space manned and cargo vehicles to operate lunar, Mars, and other programs operating in and beyond Earth orbit. We should support hypersonic research to help a private industry create a flyback first stage crew launch vehicle. We should definitely support space station operations past the year 2020. Obviously, one of the major things was cut from the program, which was a large centrifuge facility, which would have allowed us to put small mammals through their life cycle to see if mammals could survive in 1/6 gravity and 1/3 gravity. There's only other way is to take the mammals to Mars or the moon, and astronauts don't like mammals' cages in their quarters. So this is something that's a large centrifuge facility sealed from the rest of the station would be very good at.
John, final comments, please.
Okay. We need to create and place the large solar-powered propellant depots in orbit, which should be resupplied by private contractors using their own reusable tanker vehicles. Thank you very much.
Thank you.
Good afternoon. My name is David Braun, and I'm a city council member in the city of Nassau Bay. We've got about 5,000 residents, and we're located directly across the street from JSC. Our city was born when JSC was born, and many, many of our residents are employees at JSC. When talking with my neighbors who work at NASA, in addition to being proud of the overall accomplishments they have, like putting a man on the moon, they're equally proud of the technology and advancements in safety, telecommunications, and healthcare that has spun from the work they do at NASA. Even in NASA's mistakes, like the original lens on the Hubble telescope, the technology developed to correct that lens is now used in breast cancer biopsy procedures. Quoting a space technology innovation article from October 1994, a new non-surgical, less traumatic breast cancer biopsy technology based on technology from the Hubble telescope will spare women the pain, scars, and radiation exposures typically associated with the procedure. With more than 500,000 women undergoing biopsies each year, and it's estimated that by reducing the biopsy cost from $3,500 to $850 with this new technology, national health care costs will be reduced by about $1 billion annually. Isn't that a timely topic right now? And that's in 1994 dollars. Currently, through a Space Act agreement, NASA is working with the Texas Children's Hospital to share technology used to isolate vibrations on the exercise equipment on the International Space Station to help the hospital to improve their infant transporter. This transport is used to bring small preemie babies, smaller than your hand, to the hospital in Houston, where they stand a better chance of survival. Vibrations in the current transporter and the ambulance they ride in are often detrimental to the lives of these fragile infants. We're looking forward to NASA's help in finding the solutions to this vibration problem in the near future. These are just two examples of how human exploration in space leads to technology that saves lives here on Earth every day. I hope in years to come there will be many, many more. Thank you.
Appreciate your comments.
Hello there. My name is Carol Green. I want to thank the committee very much for the opportunity for public comment. People have had the need to aspire to something amazing and work together to achieve spectacular goals. Landing people on Mars and setting up bases, for example, won't occur for many years, but we need to continue the process of striving toward this goal, as well as others related to people exploring the cosmos. The need to explore sits deep within the human psyche. Teaching math and science to our children must be a priority, along with teaching critical thinking to every child. This can only be beneficial for us all. Men and women exploring space is expensive, but the technological benefits and practical advances for us who are earthbound would be many, as witnessed by what NASA has already achieved, and the costs would not be borne by our nation alone. We have several models of cooperation in space, as General Lyles and Dr. Ride have alluded to. NASA has announced an $18.69 billion budget for fiscal year 2010 to advance Earth science, including climate change research, complete the International Space Station, explore the solar system, and conduct aeronautics research. NASA plans to do all this with about 0.5% of the federal budget. As Dr. Chris Chiba has indicated, there is a need for money to be budgeted. I don't have the answer to this, but in the Apollo era, NASA received about 2% of allocated governmental funds. Just imagine. Isn't it time to increase this investment in our future? I would like to close my comments with a quote from my brother, astronomer, NASA Medal honoree, and Pulitzer Prize-winning author Carl Sagan. If we manage to avoid self-destruction so that there are future historians, our time will be remembered in part because this was when we first set sail for other worlds. In the long run, as we straighten things out down here, there will be more of us up there. There will be robot emissaries and human outposts throughout the solar system. We will become a multi-planet species. This was Carl's vision. Please let it be yours. Thank you.
Thank you very much.
Hi, my name is Lawrence Kuznets. I'm a senior scientist with USRA for Advanced EVA Systems, developing bioinformatics, talking spacesuits, but I'm actually here today as a person who gives a lot of lectures. I spent 10 years at UC Berkeley teaching a class called Mars by 2012, and I currently go out and lecture to the public. And I thought the first thing is to offer you, Norm, condolences, because every 20 years or so they seem to haul you before a committee and have you review a program just like this. So you know about SEI, you know about the 90-day study, and you also, and Sally does too, probably know one of the options of the original Freedom design was a garage from which, from a space station, we launched to the moon and Mars. That was the original exploration vision. And we went round and round in circles, and now the best thing we can say about station is exactly what several people have said. It's a great platform for working together. I was also a life science experiment manager on station, overseeing 43 experiments, and I can't really say what my opinion of that is, but you probably are well aware of it. So what I want to mention here is that I've put together a survey of all the talks I've given over the years, getting public and undergraduate and high school reaction to some of the fundamental questions from education standpoint. And vis-a-vis a comparison of Moon versus Mars. And I'm not advocating one or the other, but I thought it would be instructive to hear what my exposure to the public and to the educational community is. Public interest in the Moon, questionable. Public interest in Mars, 3.5 website hits for every human being on Earth. Soil on the Moon, not similar to Earth. Soil on Mars, similar to Earth. Atmosphere on the Moon, none. Atmosphere on Mars primarily, there is one, it's mostly CO2. Day on the Moon, 1 month. Day on Mars, 24 hours, 39 minutes. Temperature on the Moon, minus 250 to plus 250 degrees Fahrenheit simultaneously. Temperature on the Moon, cold, dry desert. Gravity on the Moon, 0.166. Gravity on Mars, 0.38 Gs. Sufficient for continued presence, probably enough to correct any problems during a zero-G transit for 6 months. But we can find that out on Earth. Transit time, 3 days, versus transit time to Mars, similar to an ISS stay, 6 months. Water on Moon, maybe. Water on Mars, yes. ISU, in situ resource utilization, not Earth-like on the Moon, Earth-like on Mars. Best analog for the Moon, vacuum chamber and ISS. Best analog for Mars, Antarctica. Risk to the Moon, understood. Risk to Mars, greater than the Moon, but less than Apollo before we went there. I could read down the whole list. The biggest worry that people expressed for going to the Moon was an amorphous goal, amorphous cost, no clear pathway. As far as going to Mars, let's go there, let's settle, let's have another place for our species to survive if some disaster happens.
Lawrence,
So-
final comments, please.
Final comments are that I think Sally made a point. NASA, not advocating any one of these things personally. The issue is, where do you go from here? NASA has always been a can-do organization. We can do, we can do, we can do. But if you look at that can-do organization within the context of a budget, we've ended up getting screwed every step of the way because we're given a budget and we say we can do it. This is now a time for, I believe, this panel to stand up and say, don't. We cannot do this job for this budget. And whatever you choose to do, you should say, we're only going to do it if you give us the budget. Thank you.
Thank you very much.
Good. My name is Jim Ackerman, but I answered a hey dummy too. So I've got a couple of questions here. I guess I want to make clear I was employed by NASA for 36 years. You got to remember I was employed. I didn't work for NASA. The contractor's supposed to do all the work. But anyway, being with NASA for 36 years was a trying environment for an engineer. But I think if we look at the problem from a bigger viewpoint, I think we can come to some conclusions that I think may help you guys out. What's the big issue with manned spaceflight today? Sally, I think you made the point as well as any. It's the budget, the cost. I mean, everybody that's talked here today has talked about problems with the budget. So, well, next question is, well, what's the biggest thing in the budget? What we want to attack the problem where it can be affected the most. What's the biggest thing in the budget? Sally, I think you came up with that too.
This is your time.
The launch vehicle, delivery to orbit. That's the big challenge. Now, okay, well, what's the big problem? What's the challenge with the budget to orbit? What makes it so high? Why is it the big issue? I've got two documents here. One, Marshall Space Flight Center, November 1968, where von Braun made the analogy that it takes about the same amount of energy to get from Earth to orbit as it takes to get from New York to Paris in an airplane. Norm, you've probably heard that before.
I've read it.
You've read that book. It's a good one. There's another one here, Leo on the Cheap. This fellow, Gordon London, wrote a book that basically says the same thing as von Braun did. If we can build a vehicle that uses low-cost propellant and is totally reusable, we ought to be able to get there for the cost of intercontinental travel, which is, by the way, about $5 to $10 a pound. You know how much it costs to get there today on the shuttle? Well, we won't talk about that. But the ones that are being proposed by COTS, by the way, our little organization proposed two and was rejected, but with COTS, it's still thousands of dollars a pound. I went to India, talked to them, tried to get them to do something inexpensive. Hey, what are you in the world? How do you think you can make it best and lower cost? Anyway, our company was rejected. Again, one more time.
Jim, final comments, please.
But the problem is that we need to get back to basics on our launch vehicle. If we can build one that uses methane at $0.05 a pound instead of solid propellants at $25 a pound, we can get the cost of delivery to orbit down, and the space program will take off like a rocket.
Thank you very much.
Good afternoon. My name is Bob Mitchell. I'm president of the Bay Area Houston Economic Partnership. So just with that title, you know that I'm not going to sit here and talk about technical or architecture or which direction you want to go. What I want to say to you, though, is I want to thank you for all the good work that you're doing for doing this. It's very important to our community. I'm not going to talk about a lot of job losses. Yes, that's very important to this region. The NASA Johnson Space Center is the heart and soul of this area. I mean, it makes us tick. But what I want to talk about is something that I hadn't heard a lot of until at the very end, and that's the public perception and how the American public feels about the space program. What I don't want to happen is for us to completely change directions. Again, I'm not going to talk about architecture, but we have to continue human space exploration. The American public today is on board with that. An example of that is last year during the budget cycle, whenever the House passed the budget with a $2 billion markup above what the President asked for, $2 billion, passed 409 to 15. The Senate passed it unanimously. Now, I can't tell you when the last time we had that kind of a support from the House and or the Senate with a $2 billion markup. So what I'm asking you to do is you look to this, listen to what the American public has to say. You look at the most recent surveys, the American public want to do human space exploration. Again, I'm not going to try to tell you how to get there, how to do it. But the worst thing that we can do as NASA is to go out and tell the public that we've made a mistake and we're going to change directions. We can't lose that public support. We lost it 6-8 years ago. You don't read in the paper any longer about the NASA waste of money. You don't read in the paper any longer that NASA doesn't have a vision. NASA does have a vision. The American public understands that. Again, we need to continue human space exploration. So hope as you go through this process and you listen to all the technical issues that arise and what we should and shouldn't do, let's not forget about the American public. Because if you don't have their support, then you're not going to get Congress's support. Thank you.
Thank you.
Hi, my name is Jake Morellis, and I work over in MOD in a constellation program in a lab that supports prototyping for mission control, and I really love being there. I have to say to you, welcome to Houston. JFK was right. The pavement outside really is as hot as the heat of reentry. And I appreciate you coming here to hear from all of us and to share your deliberations with us, because they've been very informative to me. Some of the particular insights, which I read about, but to hear them talked about, discussed firsthand is very enlightening. When you're the seventh or eighth person in line, other people have sometimes stolen your thunder, and that's okay. What the gentleman just said a moment ago is something that I wanted to talk about. There are some people that believe that NASA is adrift, and our current president has suggested as much. NASA is beset by a sense of drift, but I don't see that from where I work. I believe that we do have a vision, and it has been touched upon here some. Moon, Mars, and beyond, the constellation vision. 4 simple words. You can fit them on a mission patch. And I believe that Mars, built upon lunar, built upon ISS, is an effective way to accomplish that vision. I believe that we should go back to the moon on its own merits. Imagine if you sent Antarctic or rainforest scientists into the rainforest for 2 weeks, and that's all they could do for 50 years, was what they could learn in 2 weeks. It'd be nuts. So I believe that one option that you should present to the Congress and the President, and I understand that you're not about making recommendations, but about providing options, is the option simply to stay the course. My mom once told me that God has no grandchildren. God has to woo every generation anew. And every new generation of political leadership has to re-own the vision that their predecessors crafted. Otherwise, it's not their own. And so that's why an Augustine Commission is reformed every so often to do this sort of thing. But that's costly in a democracy, and we've kind of talked about that on the budget side. You're familiar with delta V, the cost of changing trajectory of a spacecraft? Well, there's a concept I like to speak of as delta B, budgetary cost. The delta B is the cost to change the trajectory of a space agency from one direction to another. And I think that's a legitimate consideration, and many of you have talked about that. Mike Coates and Mark Geyer both got very specific about that and very, very pointed about that earlier today. So I want to encourage you that my belief is that the United States should stay the course. We've had a vision before. In the 1960s, JFK said that our vision was, we choose the moon. Like Moon, Mars, and beyond, it's 4 simple words that got us from Rice University all the way to the Sea of Tranquility. And it informed our space program then. It informed all the things that we developed, all the technologies that we have built upon since. And like then, now, we have a vision, and I believe that we should continue to pursue it.
Jake, final comments.
Final comments. I believe that it's a risky decision politically. In some ways, you'll be criticized for it. You should be doing other things. You should be like Columbus, leaving from a different port, traveling on different ships, going to a different destination. Maybe we should go back and start over again. I think that that's a poor choice of policy. We're on a course. It's a good course. Let's stay the course. Thank you.
Thank you.
Good afternoon. My name is Robert Howard. I'm a human factors lead over at NASA for the Lunar Lander, Lunar Rover, and Lunar Outpost. And in my spare time, I volunteer with the National Society of Black Engineers. I'm president of our local chapter and director of our National Special Interest Group. I have 2 minor technical nits before I get to what I want to say. I'm a little disappointed that the ISS committee didn't look at the use of Ares 5 for cargo up mass or down mass potential. With that vehicle, it seems like an obvious gap that we've forgotten to look at what we can do with that booster, or with any of the other heavy lift vehicle concepts. Also, it bothers me that we spent so much time promoting ISS and its benefits, but we're so quick to walk away from it now. That seems short-sighted. But what I want to really get to is it seems to our detriment that we use the word space exploration and human spaceflight as if they were interchangeable. But they're really not. They're no more the same than exploration of the air is the same as aviation. Exploration is just one of many things that we should be doing in space. And I think our focus on exploration is why we lose the public. We like to think that we have the attention and imagination of the public, and we do have it of a lot of people, but we don't have it to the extent we used to have. I would speak to groups of students since I was a student myself, and I see the interest decline over time. It's not what it used to be. And I want to disagree with a lot of my colleagues that I don't think Mars is the answer. I do want to go to Mars. I want to develop Mars vehicles in my career. But I don't think that's the answer to the reasons of why we should be in space, why we should be on the moon, why we should have the space station, and so forth. When I was a child, NASA people would come and say, when you grow up, we're going to be going to Mars. Now that I'm here working at the agency, we're going out telling children, when you grow up, we're going to go to Mars. It's just pushing it over to the right and saying, don't worry about the problems. It's the next generation's duty. I think we need to own our destiny as an agency, and I think that destiny needs to be to use space to revolutionize the human experience. Apollo did that, but it was easy for Apollo. Just to go to any destination would do that because that was beyond human comprehension. That's no longer the case. And I think we would have to go to Alpha Centauri to really excite people about a destination. I think it's more about what do we do with that destination that can revolutionize humanity. And I wish we weren't going to the moon in order to go to Mars, even though I want to go to Mars. I wish we were going to the moon, and I wish our goal for going to the moon was that we would use energy on the moon so we could eliminate coal, we could eliminate the use of petroleum on Earth within 50 years. I think that's attainable. I think that's something that people would rally around because I think that would revolutionize the human experience. I wish we could go beyond what I call the boilerplate, the spin-offs, the rationales for space that have been used since I was a child. And I wish we would go to space for things that would dramatically and visibly and immediately transform life on Earth.
Thank you very much. Sir.
My name is Alex Kazaruni. I'm an intern for the summer, and I had from the University of Michigan. And I had a nice opportunity to actually draft a report with my students and submit it to the NRC, so I'd like to see General Lyles again. The quick comments I have, and sort of my comments on the cheap on the back of my dollar bill, is that if you're looking for particular sciences that ISS is supportive and can facilitate our understanding for exploration, there's a whole host of people that believe ISS is perfect for space radiation studies, South Atlantic anomaly, cracks in the radiation belts, and that's actually something that would serve the long-term exploration. So that's something that should be looked at and merited, and infrastructure built around that. So maybe that's one bullet point on a science application to take home. And then from my comments at the NRC, I had actually suggested I would actually draft a lesson plan for my computer science students where I teach the computer science 101. And so I did that. It was based on the Phobos idea and mission that Buzz Aldrin likes to promote. And I actually found at the end of the semester, they actually enjoyed that lesson much more than the other technical computer science labs we gave them because they had to think through the fundamental skill set and then choose what technical aspects apply to solve their computer program. And I think that what I noticed when I asked the students, first, they didn't hear about Phobos. They didn't realize what it was. And secondly, when they did, they realized there was a whole new place of imagination for them. So, bottom of gravity well argument or not, I think there is some traction to gain from that as far as young people enthusiasm to take away from that. As far as from what I understand about heavy lift vehicles, my only comment is I would say I would probably want to always see NASA involved in heavy lift vehicles. You're going to require that for the materials that you have to get up onto low Earth orbit or for long duration exploration. So I don't want to see COTS be the only heavy lift vehicle out there. I think NASA has to always stay in that role. And overall, I'll just make a last comment that it is nice to see the NRC take in the science community's opinion. It's even better to see you guys come out and embrace the public and the workers at each of the centers. I used to work at the Space Center before going back for my doctoral studies. And I think it's rather unique.
Alex. Final comments.
Final comments is that the transparency is nice. Obviously, there's got to be some big step changes that everybody agrees on. And I think that budget and uplift are the two big problems, and somebody's going to have to devote something to that.
Thank you. See, I think there are 4 people in line, and so that we don't miss our airplane, we'll cut it off for 4 more comments. Let's see.
My name's Alex Monchak. I'm a student in the engineering management program at the University of Houston, Clear Lake, working on new business development this semester for human space exploration, consistent with Director Coates' comment that NASA is not in the business of carrying cargo to space, but R&D, where people will pay the company I'm doing for new business development for remote access lunar development as a precursor to human exploration there. And they'll pay for launch at $100 an hour to mirror the backroom operations of a launch during the whole launch process. And they'll pay for testing before the launch, and they'll pay for planning before the testing, before the launch, and before the remote development on the moon, consistent with the market research done by Dr. Dittmar and the research done by Dr. Morn.
Thank you.
Good afternoon. Thank you for coming to Houston to be with us today. My name is Joe Mayer. I chair a national group called the Citizens for Space Exploration. We're a grassroots taxpayers group. We go to Washington, D.C. We've been doing that for about the past 20 years. This past May, we traveled to Washington, D.C., and we met with 341 congressional offices. We had representation from 24 different states. We had about 30 university students who attended with us. We are there to support and promote NASA and space exploration. I'd like to read you an excerpt of a letter that we received from one of our students, a third-year graduate student studying astrophysics at Arizona State University. I think his words reflect some of the sentiments of the young people and of students who have hopes and dreams for the future for space exploration. And I quote, "As a student in astrophysics, I recognize that the only reason the United States is the leader in the field of space and astrophysical research is because Americans, through their federal government, have continued to support the mission of NASA. But if our representatives are not continually made aware of the impact that NASA has on every aspect of American life, they will undoubtedly pare down its budget. Especially as we enter into a new, difficult economic and social era in which America risks losing this advantage on the world stage, it is critical that citizens press the issue of full funding to NASA from our elected representatives so that they too might realize how important full support of NASA is to American competitiveness, jobs, and our way of life. Astrophysical research of the sort that I do with the Hubble Space Telescope is not simply a matter of sending a telescope into orbit, as if that itself is a simple task. Hidden within the phrase orbiting laboratory or observatory is an infrastructure that makes America the envy of the world. My research is only possible because of thousands of talented engineers, machinists, designers, and managers. It is possible because America has chosen to support human space flight. And it is possible because America recognizes that the industrialization of space is a sure means of solidifying our preeminence on the global stage.
Joe, final comments, please.
You betcha. On behalf of the Citizens for Space Exploration, I want to communicate to the committee our strong emphasis that you bring to the President a set of recommendations, a set of options that will provide the United States the opportunity to continue to lead in space, to derive benefits from space, and to offer this student and other students who will follow behind him a hope and a promise for the future. And I thank you very much.
Thank you for your comments.
Hi, my name is Jeff Bridge. I'm an undergraduate engineering student at Rice University. I've heard a lot of talk about how the space program needs to reflect what the national goals are for the space program. But I haven't heard very specific discussion among these 10 people of what those goals actually are. And I think that if you're going to form a set of options for the space program that reflect what those goals are, that you need to discuss them among yourselves. I have my own biases about what is a good goal, in particular, exploration of Mars. And I think that the reason why that is a good goal is because it involves going where people have not gone before. And I think that we all know that there's a lack of young people going into math and science, and I've seen that in my peers as well. And I think that only going and doing something that we have not done before is the thing that will inspire more people to join the space program. Thank you.
Thank you very much. And the last comment.
My name is Candy Torres, and my parents were born in Puerto Rico, and so it's a little different cultural perspective. I wanted to be an astronaut very young. I applied the same time Sally did. If I weren't too short and so nearsighted, I might have had a chance. But I'm here. I grew up in New Jersey, born in New York, lived in a housing project. Yes, it was in Bronx. In that time period, it was very difficult for women to struggle, but I did it. But you know, I've also taught at an alternative high school where the kids have been in prison or they've had babies when they were young. I could go on. So I've always been socially sensitive to the aspect of space exploration. I would like to see a vision that is worded where people in the inner city or other parts, cultures, can visualize themselves doing things, not necessarily just as an astronaut. And nothing to say about astronauts. I was a flight controller, and I've worked both programs. But that's part of the problem, because I did do research for my master's degree in studies of the future, and the polls, the people are not actively supported. That's not important. What you need is the demographics don't match up. And you can see the results of that in the audience. We need to really get more people involved, but on their level, not from position up, down, but to really get in there and tell them, you can do it. Thank you.
Thank you very much for those words. We appreciate all the public comments, both today and at other occasions. Let me just say, I think you can see that our task is a daunting one. We have 35 days remaining to resolve these issues. Today we've just discussed only really the tip of the iceberg, so we'll continue on tomorrow. And with that, on behalf of all my colleagues on the committee, thank everyone in this room for your interest in the discussions. I guess this may be on television too. I didn't ask, but if it is, thank the folks who are out there watching in that environment. So this meeting is adjourned.